Assalamualaikum and hi. Today our group will be present about the question that we have discussed. So we are from group 3 and our members is me, Khairi Azman bin Ahmad Puat, Muhammad Hafiz bin Muhammad Zulkifli, Masmira binti Muhammad Abdul Ghani, Nur Maliha binti Abdul Rahim, Farah Izzati binti Ahmad Rizal, and lastly Fatin Nazira binti Nordin. Next, for the question, section 1-1, question number 3. The question is ask draw the gradient field corresponding to the function. As shown as in the slide, this is the vector field for the function fxy equal to x y squared. We just assume any point in the function fxy, which is shown at the right side, 0, 1, 0, 0.51, 1, 1. For this point, we just assume any point. And then substitute point that we assumed earlier into x and y squared to get the direction. And for the value y and for the value x and y squared, as shown as the center graph, which is 0, 1, 0 0.5, 1, 1, 1. We can say from the function value for y squared, the direction will be positive direction because any number or any point for square root for power of 2 or square will be positive number. So after that we get the destination of our point, which is f nu x and y squared. So I pass the next slide to Farah Izzati.
Okay, for section 1, 2, the question which of the points P equal to 8, negative 9, 3 and points Q equal to negative 6, 4, negative 5 is closest to the xz plane. Okay, since it is xz plane, we know that y equal to 0, which point P will become P equal to x, 8, 0 and 3, and the distance from 0 to negative 9 is 9, and point Q will become Q equal to negative 6, 0 and negative 5, and the distance from 0 to 4 is 4. So we conclude point Q is the closest to the xz plane.
Next is section 1.3. Question number 3 is give the equation of the line in vector form, parametric form, and symmetric form for the line through the point negative 7 to 4 and orthogonal to both v equal to 0, negative 9, 1 and w 3i plus j minus 4k. Okay, first we assume that 0 that v vector v which is 0, negative 9, 1 is intersection to the line x yz plane because x axis is 0. Okay, first parametric form is x plus 7 equal to 3t, y minus 2 equal to t, z minus 4 equal to negative 4t, and symmetric form is x plus 7 over 3 equal to y minus 2 over 1 equal to z minus 4 over negative 4. And the last is vector form is r equal to in bracket negative 7 plus 3t close bracket I plus in bracket 2 plus T close bracket J plus 4 minus 4T close bracket K.
For section 1-4, question number 3. The plane contain the point negative 8, 3, 7 and the parallel to the plane given by 4x plus 8y minus 2z equal to 45. So we have to write down the equation of plane. For the solution, we must know about equation of the plane upon minus normal form. So n is a normal vector and p is a point. So 4 is a A, 8 is a B, negative 2C. For negative 8, x1 3, y1 and 7 z1. So we substitute into this formula and we must solve this equation and we will get 4x plus 8y minus 2z equal to negative 22. So this is the answer. Okay.
Okay, for section 1.5, question number 3. Find the domain of the given function. Given f(xy) equal to square root 1 over x square minus 1 over y square, for the function f(xy) to have real value, the quantity under the square root must be non-negative, which is 1 over x square minus 1 over y square more and equal to 0. The inequality can be written in a form 1 over x square plus 1 over y square less and equal to 0. Therefore, the domain of f(xy) is xy in an element of r's power of 2, which is 1 over x square minus 1 over y square less than equal to 0. Next, I will pass to Fatih Nazira.
Next, I will explain the solution for 1.6. The question is find the domain of the given vector rt equal to ln t plus 7 and ln t minus 3. So the solution is bear in mind for ln a must be larger than 0. So in this case, we will solve two parts, which is first part is ln t plus 7 and the second part is ln t minus 3. For the first part, we let gt equal to ln t plus 7. Now we can apply ln a, which is a larger than 0. So our t plus 7 is larger than 0. We solve to find t and t become larger than negative 7. Since our t is larger than 0, we know our domain for ln t plus 7 is negative 7 until infinity. Next, for the second part, we let ht equal to t minus 3. So we solve for t minus 3 larger than 0, and our t will become t larger than 3. So our domain for ln t minus 3 is 3 until infinity. So we have to find the intersection between negative 7 until infinity and 3 until infinity. So from the figure, we can see here the domain for rt is the set of t that satisfying domain for gt and ht, which is 3 until infinity. Okay, so next section 1.7. The question is identify the graph of the vector function without sketching the graph. We can see here the question is rt equal to x equal to 2, y equal to 6 cos t, and z equal to 6 sin t. So the parametric equation for the curve is x equal to 2, y equal to 6 cos t, and z equal to 6 sin t. First, what we do is we ignore the x for a bit. Note that one possible way to parameterize a circle is y equal to r cos t and z equal to r sin t. So if we look in this question, our r is 6 actually. So in this question, the parametric equation for y and z give a circle of radius 6 centered on the origin or about the x-axis since we are in R cube. Okay, so now all the parametric equation here tell us is that no matter what is going on, the graph of the x coordinate must be in 2 since we look at x equal to 2. So we get a circle of radius 6 centered on the x-axis and at the level of x equal to 2. Note that as long as two of the term are a sine and a cosine, so in this case we can see y equal to 6 cos t and z equal to 6 sin t. And the other is a fixed number. So the other is a fixed number. We can see here x equal to 2. Then we will have a circle that is centered on the axis that is given by the fixed number. That's all from me. Next, I will pass to the Madiha.
Okay, for the section 1.8, question number 3. Evaluate the given limit. Given limit t to 0 is sin t over 2t, 1 minus cos t over t, and negative 3. We substitute the limit t to 0 in each element. For the limit t to 0, sin t over 2t, we factorize it and get 1 over 2 limit t to 0 sin t over t. By applying L'Hopital rule, we get 1 over 2 limit t to 0 cos t over t. And we get 1 over 2 in bracket cos 0 over t close bracket, and we get the answer is 1 over 2. Next. For limit t to 0, 1 minus cos t over t. By applying L'Hopital rule, limit t to 0 is equal to sin t over 1. Then sin 0 over 1. We will get 0. For limit t to 0, negative 3, we will get negative 3. Therefore, the answer is 1 over 2, 0, and negative 3. Next, I will pass to Hafiz.
Okay, for section 1.9. So, question number 3. We must integrate vector r, and the vector r we know t cos pi t, 8t minus 2, and 12 t cube minus exponent 2t. So we substitute into the formula integration of vector r. And second step, so we separate into 3 parts, iaitu for the part 1, part 2, and part 3. So for the part 1, we must for the part 1 is integration t cos pi t dt. So this equation we must use integration by part. So we know t is equal to u, du equal to dt, and dv is cos pi t, and v equal to sin pi t over pi. So we use uv minus integration v du is a integration by part formula, and we substitute into this formula, and we will get the sin pi t over pi minus integration of sin pi t over pi dt. And we solve this equation and we will get t sine pi t over pi plus cos pi t over pi square. And for the step 3, we solve the second part, which is 8t minus 2 dt. So this use the normal integration and we will get 4t square minus 2t. And step 4, we settle down the part 3, which is 12t cube minus exponent to the power of 2t dt. So we will get 3t to the power of 4 minus exponent to the power of 2t over 2. And the step 5, we combine the all three parts answer into we substitute three parts answer into the formula vector of integration of r vector r, and we will get negative 2 over pi square 2 5 minus exponent 2 over 2. So that's all.
Okay, for section 110, the question is find the unit tangent vector for vector rt equal to ln 60 exponent to the power of 1 minus t and 5t. Okay, first step is we differentiate rt and we got 1 over t, negative exponent 1 to the power of 1 minus t and 5. Okay, next with the formula of the tangent, which is tt equal to first derivative of r over norm first derivative of rt. Next, we find norm r prime t and we got set 1 minus exponent to the power of 2 minus 2t t square plus 25 t square over t. And we use the formula again and we substitute all the solution and we got next and, and we got the final tangent vector is as shown as on the slide. Next. Okay, first for I, we should simplify the answer, which is for I. We simplify 1 over t divided by set 1 minus exponent to the power of 2 minus 2t, t square plus 25t square over t, and we got the answer of I as shown as on the slide. Next, for J, we use the same step and we got the answer as shown on the slide. And next for K, we use the same step and we got K equal to 5t set 1 minus exponent to the power of 2 minus 2t t square plus 25t square over 1 minus exponent to the power of 2 minus 2t t square plus 25t square. And then we substitute all the solution after we simplify and we substitute 0 into t, we got the tangent vector is 1, 0, 0. And we substitute again the value of 1 into t and we got the tangent vector is 1 over 5, comma, negative 1 over 25, comma, 1. Next I will pass to Farah.
Okay, for section 111, the question is find the vector for each the following vector functions. Okay, r vector t equal to cos omega t, and sine omega t. So we differentiate it. For the first derivative, we get negative omega sin omega t, 1, and omega cos omega t. Then for second derivative, we get negative omega cos omega t, 0, and negative omega sine omega t. Then we use cross product and we substitute the vector into this formula and we get uh, next I equal to negative omega sine omega t, j equal to omega squared, and k equal to omega cos omega t. Okay, after we get a new vector, we use the new formula where k next slide, where k equal to norm first derivative times second derivative divided by norm first derivative power of 3. And we substitute the vector into the formula. And finally, we get the final answer is square root omega squared plus omega power of 4 divided by square root omega squared plus 1. Okay, for the next section, I pass to Khairi Hazman.
Okay, for the last section 112, which is the answer, determine the tangential and normal components of acceleration for the object whose position vector is given is vector of r equal to 5t, 1 minus 2t, and 4t power of 3 over 2. To determine the tangential and normal component of acceleration, first, we need to find the velocity and the acceleration of this function. The velocity vector is shown as that, which is v represent as velocity, which is same to first derivative of r vector, and it is 5 negative 2 6t power of 1 over 2. And then we define the acceleration vector as shown as that, which is a represent to acceleration, which is a is second derivative of r vector, which is the answer is 0 0 3 t power of negative 1 over 2. To find the tangential components of acceleration, we need to declare the component in tangential formula, which is the tangent component in tangential formula is at equal to d squared s over dt squared. We know that ds over dt is equal to norm of first derivative of r, which is norm of 5 negative 2 6t power of 1 over 2. And then we get square root 29 plus 36t. Sub into at, which is component in tangential formula, which is this is tangential. At equal to d square s over dt squared. So we get 18 over square root 29 plus 36t. After that, the way to find normal component of acceleration, which is an, equal to square root norm of acceleration power of 2 minus tangential component power of 2. So we can get the answer is shown as in the slide, which is square root 261t power of -1 over square root 29 plus 36t. Hence, we also can find curvature function, which is the normal component of acceleration, an, divided by ds over dt square, equal to 3 square root 39 t power of -1 over 36t plus 29. So that's all from us. Thank you for your cooperation.